So the first class is energy classification and the energy need in India. First, we need to define what is energy. Just hold on, let me share my screen. Okay, the screen is clearly visible. So, what is energy? Energy is basically the capability of doing work. We calculate it as power divided by time. Now, the various forms of energy are thermal, electrical, mechanical, and chemical, and many more. But the major that we are going to discuss in this class, because it's basically a solar class, is of electrical and thermal. Thermal is basically heat energy. Now, if we talk about the energy sources, the global primary energy sources we can say as coal, or the basic conventional energy. We generate it from coal. Coal, you can see, is the most abundant, but it is most abundant in USA, followed by Russia, China, and lastly India. Now, coal, as we know, is not though abundant in the nature. It's a high energy, high grade energy. It generates a lot amount of electricity. Most of the conventional energies are from coal, but it has lot amount of disadvantages. For example, it is a polluted source of energy. It has high health concern. Whenever it is burned, it generates CO2 and sulfur. And even sometimes if the low quality of coal is not burnt properly, like we can use high quality of coal for generating electricity and low quality. If the low quality is not burnt properly, it may generate sulfur, mercury, and other health diseases gases. After coal, the most abundantly used energy source is oil. We all know that oil is mostly available in the Arabian countries, for example, Saudi Arabia. After that comes gas, or the natural gas, which we call natural gas is highly available in Russia. But we can say that this type of fuel, which is called as fossil fuels, are though available nowadays, but it won't be available for a longer time. And nowadays, dearth has come, which is causing the rate of electricity to increase day by day. So we need to move from these fossil fuel sources to other sources. So the first thought source was nuclear energy. Now, first to discuss about the fossil fuels, we can see that production of, if we see about the production, the highest producer is China, followed by USA, then India. Similarly, in terms of consumption. And in case of oil, we can see United States is the one who consumed oil the most, and followed by the rest of the world. Now, just to move, we have moved first of all to move from conventional energy to any other source. We are going to move to the nuclear energy. The first thing that has been done all over the world was nuclear energy, because the nuclear energy source, that is uranium, which is going to come, is though not abundant, but is available all over the world. And if we see by the time frame by which it is basically goes to half-life, is a longer time. So it's more or less energy which can be lasted for a longer time. But there are major possibilities not at all eco-friendly, because the dumping and maintaining the plant is very much hazardous. So as we talk about the Indian energy scenario, the Indian primary energy reserve, as we say, the first is oil, like after coal is oil, natural gas, then nuclear power. As we already told, 14 nuclear power stations has been constructed all over India, because nuclear power station can be constructed anywhere. It doesn't need to have the vicinity to any water source in case of hydro or thermal power plants. So nuclear power plant can be even constructed near to the demand centers, like near to any cities and any cities or any places where the demand is there, the industrial places. So the nuclear energy, as we told, 14 plants starting from Tarapur, Maharashtra, Kota, Rajasthan, Kalavakkam, that's in Tamil Nadu, Narora, Uttar Pradesh, Kalpakra, Gujarat, and so on and so forth. There are multiple plants, 14 plants in total. The total capacity, installed capacity till date is 3310 megawatt in case of nuclear power plants. Now, if we classify the energy sources, it will be in two terms. One is in commercial matter, one is in the form of renewable. If we can renew a source, we call this a renewable sources. For example, any natural sources. For example, solar, wind, biomass, even hydro, because hydro is a type of energy which can be renewed throughout the time. Non-renewable is energy which can't be renewed. For example, if we talk about coal, oil, even nuclear, if we use it once, we can't renew it again. So all these type of energies are basically non-renewable energy. There is no relation between a renewable energy or conventional energy. Conventional energy as such, which is used in conventions, are generally used for the electricity generation and distribution purpose. For example, coal is the most abundantly used in India, the thermal power stations, the hydro power stations, nuclear power stations even. But nowadays, solar, as so much of the solar energy is getting generated and used nowadays, it is also considered as a conventional energy. So solar is, though a renewable energy, is considered as a conventional energy. Now, in terms of commercial, if we talk about commercial classification, non-commercial, energy which is basically built by the DISCOM or any other energy partner of a country is called as commercial energy. For example, we build energy for any conventional energies. For example, coal, the thermal energy, hydro energy, nuclear energy, solar energy, in some cases wind energy, they are commercial energies. But the energies which are not being built by any DISCOM or used in a standalone or a community purpose. For example, biomass, geothermal, it is not used in abundance, so that's why it is not built. So it is called a non-commercial energy. They are not used in commercial matter. So as we break down the word non-renewable resources, it means non-renewable, which can't be renewed, and resource, which is basically the fuel. So non-renewable energy resources is a resource which can be renewed, regrown, remade, and can be used throughout the time. The fuel doesn't end. There is no dearth of the fuel. But in case of renewable energy, for example, coal, petroleum, natural gas, it will be in dearth or replenished in a short period of time. That's why it's called the fossil fuels. Nuclear, as we already mentioned, though you can be used for a longer time than the fossil fuels, but once it is used, it can't be recreated. The amount of uranium used to generate electricity can't be recreated again. That's why it is called as a non-renewable energy. Now, just to come to the, as we are talking about the non-renewable energy sources, just to understand what is renewable energy sources. Renewable energy sources are the sources where we are using natural energy to generate electricity or any other energy need. For example, sunlight, wind, rain, tides, waves, geothermal energy, etc., etc. In India, as we know, solar is the most abundant. So if we are coming to the renewable sources of energy, we are going to discuss about the five major. Though we are only concentrating on solar in this course, the five major are solar, wind, geothermal, biomass, and hydro. As we said, hydro being the source, being water, it can be used again and again. It can be renewed. So that is called as a renewable energy. Now, to understand what is the solar energy, let us see a video.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the PN junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the PN junction, they'll only go one way. The electron is drawn to the N side, while the hole is drawn to the P side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades. So what's stopping us from being completely reliant on solar power? There are political factors at play, not to mention businesses that lobby to maintain the status quo. But for now, let's focus on the physical and logistical challenges. And the most obvious of those is that solar energy is unevenly distributed across the planet. Some areas are sunnier than others. It's also inconsistent. Less solar energy is available on cloudy days or at night. So a total reliance would require efficient ways to get electricity from sunny spots to cloudy ones, and effective storage of energy. The efficiency of the cell itself is a challenge too. If sunlight is reflected instead of absorbed, or if dislodged electrons fall back into a hole before going through the circuit, that photon's energy is lost. The most efficient solar cell yet still only converts 46% of the available sunlight to electricity, and most commercial systems are currently 15 to 20% efficient. In spite of these limitations, it actually would be possible to power the entire world with today's solar technology. We'd need the funding to build the infrastructure and a good deal of space. Estimates range from tens to hundreds of thousands of square miles. Which seems like a lot, but the Sahara Desert alone is over 3 million square miles in area. Meanwhile, solar cells are getting better, cheaper, and are competing with electricity from the grid. And innovations like floating solar farms may change the landscape entirely. Thought experiments aside, there's the fact that over 1 billion people don't have access to a reliable electric grid, especially in developing countries, many of which are sunny. So in places like that, solar energy is already much cheaper and safer than available alternatives like kerosene. For, say, Finland or Seattle, though, effective solar energy may still be a little way off.
The next to discuss is basically the wind energy, right? So first let us check what is wind energy, what is the basic of the wind energy. Let's check a video. This video doesn't have a sound, so you just need to see everything is written on the video. Like where the wind energy, previously it was used where, and nowadays how wind energy is basically being harnessed. If you see, this is basically a photo of a wind turbine. Fine. A wind turbine is just like a normal fan, a ceiling fan that we use in our home. It has 3 blades connected to a hub. If you can see, the cylindrical part is called as a hub, in which the blades are connected. Right?
Yes, sir.
The hub is connected, the blades are basically connected to a nacelle. What does a nacelle contains? It contains, first the blade is connected, like we are converting a mechanical energy to a electrical energy.
Yes.
Yes. So what we are doing is we are connecting it to a mechanical coupler first. You can see the blades are connected to a green mechanical coupler which is connected to a shaft.
Yes, sir.
The shaft is connected to the generator, which generates electricity. Fine. So this generator is basically located at the nacelle, like the room in which the generator is fitted inside the wind turbine is called a nacelle. Now, a wind turbine blade basically rotate at 15 to 20 RPM, that is rotations per minute, for generating electricity. There are two speeds which a wind turbine needs to maintain. That is, if it is above 12 RPM, it can start generation. If it is less than 12 RPM, a wind turbine can't start generation.
Okay.
This is called the cut-in voltage. Okay? I'm just writing the name. It is called as the, just hold on. Cut in voltage or / speed. That is the minimum wind velocity that is required to turn on the wind turbine. Similarly, the maximum speed.
How much the voltage required?
The speed is 12 RPM. 12 rotations per minute.
Voltage required? Minimum voltage required? To
12. 1, 2.
Okay.
12 RPM. The minimum speed required is 12 RPM.
Okay.
Fine?
Yes, sir.
And the maximum speed up to which a wind turbine can rotate is called as cut-off velocity. It is called as a cut-off velocity or speed. That is generally 40 RPM for a wind turbine. Clear?
Okay, sir.
Now let's see the video. So you can see the wind is flowing, blades are rotating, and ultimately it is getting fed to the generator. From generator is converted to electricity and providing it through the powerhouse to our houses. So from here we can see a wind turbine usually takes less than 1 acre of land.
Okay.
And the base can be used for vegetation, except the wind turbine part, the base is not wasted. So you can use it for agriculture or vegetation purpose.
Yes, sir.
Now, if we see a wind turbine, generally what happens in solar can only operate when the sun rises. That is 8 to 9 AM in the morning till 5 to 6 PM in the evening. But a wind turbine can run 70 to 80% of the day. It can even run in night.
Yes, sir.
So you can see UK has 1 turbine per 100 kilometers square. Germany has 7, Denmark has 11. And a single wind turbine, if we talk about 1 megawatt wind turbine, it can nearly power 1219, 1200 homes. Only one wind turbine.
Okay.
It's just a figures which is showing what it can power. And a wind turbine is nearly equal to 1600 solar panels. Sorry, 16,000. So it is much more effective than solar. Yeah, tell me.
Yes, sir.
But it has one problem than solar. Solar can generate even on a cloudy day when it has temperature or heat. But in wind power, it needs to have a uniform direction wind. Like if the wind is flowing in non-uniform direction, for example, for the first half an hour it is blowing from west, after that it is blowing from east, and so on and so forth, a wind turbine can't generate. So the wind flow should be from one direction or uniform direction, and a minimum speed of 12 rpm needs to be maintained by the wind.
Yes, sir.
So you can see from here it is shown, if we like invest in wind, generally the return of investment time is 3 years, whereas the wind plant nearly runs for 20 to 25 years. So it's a free energy after a certain period of time. And as it is removing carbon dioxide, it's like a friendly energy, friendly energy. Even on the other hand, if we see by water conservation, as wind doesn't use water, it generally saves 1,74,000 bathtubs of water a year. Now, you can see there are two questions, what is onshore and what is offshore. There are two types of wind plant or wind turbines. Onshore is the wind turbine that is basically raised on a land. Offshore is wind turbine which is basically raised on a sea. Because in seashore there is much wind flow. So wind turbine which is basically installed on a sea is called as an offshore wind turbine. Previous, like the old wind turbines used to produce a sound, whoosh sound. So wherever it is installed, the nearby places has a noise pollution. Nowadays, with modern technologies, all we can call this BLDC. If you are an electrical engineer, right?
Yes, sir.
So BLDC is brushless DC motors. So if you are using brushless DC motors or DC generators to generate wind power, the whoosh sound is not there in the wind turbine anymore. From here you can see what's the cost difference of using wind power and conventional energies nowadays. It's the cheapest form of energy available in earth, but the problem in India is for generating wind power, the wind blade or the hub needs to be at the correct height where the wind flow is maximum. But in India, the wind flow pattern changes. So in India, there is not much amount of wind turbine available. Yes, there are certain in Gujarat, Maharashtra, and Chennai on the coast, but not very much compared to solar.
Yes, sir.
Next comes geothermal. Geothermal is energy where the heat of the earth is basically used for generating the energy. That's why it's called the geothermal. Geo is earth, thermal is heat. So
Heat.
let's check a video. I hope you can hear it.
Yes, sir.
It is basically showing that, as we all know, the like any like earth has been formed from Big Bang theory, right? So
Yes.
according to that, it was basically a form of lava which has like frozen down on time and ultimately earth has formed. But the core of the earth, it has still has a lot amount of heat or energy which can be extracted as geothermal energy and can be used as electricity.
Yes, sir.
80 kilometers down. In some places it is far above. This is where we call this as hot springs. Like whenever we go to excavate oil, sometimes we find that instead of oil we are getting hot water. That's hot spring. That is nothing but it shows that the geothermal energy line in that particular place is not very deep, it's very near. That's why the water there has formed into hot springs.
Yes, sir.
First geothermal plant was established at Italy in 1911.
Yes, sir.
Is there any query regarding the three types of geothermal power plant as been told?
Sir, actually, what is the function of vessel?
What is the function of?
Vessel.
Just to store the, like, if you have a dry steam, just to store the dry steam or flash steam, just to, in the case of dry steam, it's only used for storage. In flash steam, is used for conversion. The unused part, like the vessel, is the part where the whole dry steel is basically being stored, and ultimately it is fed to the generator for generating electricity. So if we are using a dry steam, it is called as a dry steam. If you are using flash stream or lava, it is called as a flash stream. Combination of both is called as a binary cycle.
Yes, sir.
So clear?
Yes, sir.
But the point is, now till now we have learned three types. One is solar, which is the most abundant because sunlight is most abundant all over the world, especially in India. Next is wind, which is the cheapest form of energy, but not so much abundant in India. Last is geothermal, which is really abundant all over the world. But yes, in few places it's abundant so that we can use it, which in India we generally called as hot springs. The next energy is biomass. Biomass is basically used as a standalone type of energy, like wherever you need to use for only one home, mainly in rural areas where you have cow dung and more of biomass fuels, there you can use as biomass energy, right? So just to check what is biomass energy and how it is generally used. So you can see that's the basic of biomass, where we are using the biomass, different types of biomass, cow dung and any type of biomass fuel for generating electricity. Nowadays, you can see that the municipalities are using two types of dustbins, right? One is a green dustbin for using the products which can be renewable can be dumped on the green dustbin, and one is the grey dustbin where plastics and other materials are being basically dumped. This is basically used for generating waste management. From this waste management, from the green dustbin products, we can also generate electricity. So many of the municipalities nowadays are coming up with the ideas of generating electricity by the household waste, which is basically being put in the green dustbin. So it is not directly a biomass, but it's a type. Biomass is anything related to, like, you need to have any animal dung or parts of any living plant. As it is not so, in case of dustbin, it is the waste which we are using. We call it as a waste management. But process is more or less same as biomass. Clear?
Yes, sir.
Last is hydro. Now you can ask why renewable, like hydro is considered as a renewable energy. As we have, like in the previous part, as we have discussed, the solar is a renewable energy but a commercial energy. Similarly, nowadays even you can say solar is a conventional energy. Why? What is conventional energy? People who are using energy in a conventional manner, in a regular purpose. Solar energy nowadays is using in very regular purpose. You can see in schools, colleges, in industries, even in households, solar plants are getting installed.
Yes.
So the usage of solar energy is getting abundant day by day. That's why it has become a renewable, conventional energy and also a commercial energy where it is built. Similarly, hydro is basically a generation from water. It's a generation from water. Water sources are more or less renewable. There is never dearth of water resources, except like seasonal wise there can be like difference of flow, but there should be water. That's why hydro nowadays, though a conventional energy, is considered as a renewable energy. Now let's see just the basic of hydro energy, how it generates electricity. From this video, we have seen that there are two types. One is dam, one is runoff river. What is a dam? Dam is in places where we have the capability of storing the water in a reservoir and then use it, right?
Yes.
But runoff river is like you have a stream, you have a waterfall. You don't have the place. It's a mountainous area, so you don't have the place to store the water in the reservoir. In that cases, we generally use the general flow. In case of dam, we create an artificial flow. But in case of runoff river, we use the general flow of the river. That's why it is called as a runoff river hydro plant.
Yes, sir.
In the first part, it has been shown when the water is like we are stopping the flow of the river. We are storing it in a higher place called as a higher reservoir, right? After that, we are making a tunnel and putting all the equipments, for example, generator for generating the electricity, and letting the water flow to the lower level, or which is called as a lower reservoir. In case where the electricity is generated from a higher reservoir to a lower reservoir water flow, it is a normal hydropower plant which we used to know. But in some cases, when we are using the lower reservoir to high reservoir water flow by pumping it and generating electricity, it is called as a pumped reservoir, pumped hydro power plants. For example, when in 2014, when there was a blackout in India, in BBC, the same hydro technology has been used as a pumped reservoir to start all the conventional coal plants, the thermal plants. Because in thermal plants, boilers need an auxiliary power to switch it on. You know, you are aware of it, right?
Yes, sir.
Without auxiliary power, it's not possible. So when there was a blackout,
Yes, sir.
due to the blackout, all the auxiliary powers were switched off. So there was no power supply. So what was done is the pump power supply, the pumped water station, pumped the water from lower reservoir to the higher reservoir to generate electricity, and by that way they have started the auxiliary powers and ultimately all the thermal power stations. Next, which we are seeing here, is basically a runoff river. Like we will just create a separate path line for generating electricity where we don't have the capability or the space or the infrastructure cost to create a reservoir, because for creating a reservoir it's very costly. The infrastructure cost is very high for a hydropower plant. So when we don't have that capability or space issue, we use runoff river.
Yes, sir.
Here you can see major 2 points. One is reliable, cost competitive is all we can understand, but one is reliable, one is base load power. What is that? In India, due to this COVID-19, in few days before, our respective Prime Minister has told everyone to switch off the lights at 9 p.m. Right? What happened in that case is,
Yes, sir.
when we are changing a huge amount of power at a certain time, like let's say we are consuming 100 megawatt power at a certain time, and suddenly we are like changing it to 50 megawatt. Suddenly, what happens? The power swing curve is not able to keep the frequency in the level in which it can generate. So there is a great chance of droppage of power or power cut. Now,
Yes,
there are two types of power plant. One is our thermal power plant, in which boilers are required to switch on or switch off for a longer time. Like a boiler need 8 to 12 hours to warm up to start electricity generation. But that is not in case of hydro. That's why for using base load, like for example, for 100 megawatt, there should be a base load of 20 to 25 megawatt, which is a load that will be always there whatever happens. So for base load plant, we generally prefer using hydro.
Yes, sir.
Well, we are well aware of the flood control. This is the reason as it is not very much eco-friendly. It is not considered as an eco-friendly source of energy, though it is a renewable source of energy, conventional source of energy, but like solar or wind, it is not considered as an eco-friendly source of energy.
Yes, sir.
Now, as we have discussed the 5 major renewable sources of energy: solar, wind, geothermal, biomass, hydro, right? The most,
Yes,
in
sir.
our course, we are going to concentrate mainly on the solar energy. So as we know, solar energy comes from the sun, and as sun rays every day, so it's a renewable energy. What are the direct applications of solar energy? Here you can see we can use it as flat plate collectors, like that is our modules from which we can generate electricity.
Yes,
We
sir.
can use it as solar concentrating collectors. Concentrating collectors are generally used to convert the solar rays to heat energy. We can use it for water heating. Solar water heaters used in hotels and restaurants, even in residential households. Nowadays, air conditioning can be also be done using solar, so it is called a solar air conditioning. Cooking, we are well aware of solar cookers. Distillation is possible. Agricultural products, solar drying is possible. Greenhouses can be created using solar. Like we can trap the solar energy, the longer length of the solar energy, and we can ensure that the shorter length is not going out of the room. That is called as solar greenhouses. And the most commonly used is solar photovoltaic, which are we going to discuss on the due course of class.
Yes, sir.
From here we can see wind power. As we say in India, the wind power has the most installed capacity, but the solar nowadays is overcoming the same. In case of solar, we use it in mainly 3 parts. First is the utility grid. Utility grid is where we are connecting the solar power electricity to the grid, which is our basically the course. How to connect solar power to the grid. It is called as utility grid power. Rooftop utility grid. Utility is where we are using it in a megawatt scale. In case of ground mounted, we have megawatts of area where we can use generated for solar electricity. Even rooftop,
Yes,
your
sir.
rooftop can be used for installing solar energy, which can be integrated in the grid, which is called as a grid tied solar power plants. After that, we come into off-grid application. The off-grid means the same solar power plant which is not connected to grid, but rather we use a storage device or a battery to store the power for usage when there is no solar light or there is no sunlight. Generally in the night, it is used in the rural areas where there is like, what is the problem with the grid tied power plant is, if there is power cut, the grid tied power plant can't generate electricity. So in places or rural areas where there is frequent power cut, it's better to use off-grid power plant rather than grid connected power plants. Next is solar collectors. As we have seen, the solar collectors basically used for collecting heat energy for solar dryer or solar cooking systems. Like in Brahma Kumaris in Rajasthan, there is a big solar collector which they use for cooking purpose of the whole Brahma Kumari ashram. Whoever candidate is there in the Brahma Kumari ashram, the whole cooking is done by using solar heat through solar collectors.
Yes, sir.
Next, as we know that solar energy can be utilized in 2 methods. One is direct, which is the main method. One is photovoltaic, that is electricity, and next is thermal or heat. But solar energy is also used in some other methods, like for heating up water, solar water heating system. So these are the like indirect solar energy methods. Wind. Why we consider wind as an indirect solar energy? Reason: the solar energy determines the wind flow pattern. In the world, the wind flow pattern is basically determined by the solar energies. That's why the wind is considered as one of the indirect method. Biomass, same. Fermentation of biomass fuel depends on solar. Wave energy, the rise and fall of waves in an ocean depends on solar energy. Ocean temperature, the temperature in day and night depends on solar energy. Even the
Yes.
current flow, water current flow in the marine or in the seas or oceans are basically being monitored by solar. So it is also a type of solar energy. As we have already seen wind energy and all, just a summary. As we have learned, what is a renewable energy? As energy which is eco-friendly, which can be renewed on time to time. Non-renewable energies are energies which can't be renewed, but both have something common, which is it can both can be used as commercial or conventional energy. For example, solar. Both the energies can be eco-friendly or can't be. For example, hydro being a renewable energy, but it is not at all eco-friendly,
Yes, sir.
right? So
Yes, sir.
renewable versus non-renewable energy, what are the basic renewable sources, what are the basic non-renewable sources. So we will end up our class here today in the first session, and in the next session we are going to learn what is the basic photovoltaic system for which we need to make the design, what are the different parts of it, what is the basic difference between a on-grid or a off-grid system. Here, most of the videos that has been taken are basically from TEDx or other YouTube sources for the solar, the wind energy, the tidal energy, the hydro energy, whatever videos are shown. It is just for the purpose of making the knowledge more understandable. And the video quotes are given in the link below. So if you want to see that videos, it can be also seen from that link given in the description box. And as I've mentioned, please do like, subscribe, and share, and hit the bell icon for further updates. Thank you.